Hey, welcome to another Drone Doc episode. I'm your host, the Drone Doc, and in today's episode, we're going to be talking about ESCs. A little bit about voltage ratings, a little bit about current ratings, the benefits to different types of ESCs, and also a little bit about the anatomy of what's on an ESC itself. Let's get started. Now, ESCs are an essential part of the drone, and the performance of the drone is entirely dependent on the variable speed of the motors. So ESCs are powered from direct current, so essentially your LiPo battery. They take the motor signal from the flight controller output, and they provide a three-phase alternating current to power the motor. So they offer high resolution, high power, and high frequency outputs to drive your motors. Now let's talk about the different types of ESCs. You have 4-in-1 ESCs and you have single ESCs. So 4-in-1 ESCs simply means that 4 ESCs are mounted on a single circuit board. Those ESCs can be moved from the arms of the drone into the center of the drone where the CG is more centralized. Now let's talk about some of the benefits of an individual ESC. In the event of a crash, if you do crash, you can replace one ESC rather than 4 at once. So the cost is typically a quarter of the price of a 4-in-1 ESC. There's also slightly more cooling effect when the single ESCs are mounted on the arms. Though I will say there are some disadvantages to single ESCs. In fact, the wiring can be a bit more complex when the soldering is involved. Typically, you always need a power distribution board to distribute that incoming voltage from your LiPo battery to each individual ESC. Also, having 4 ESCs on the arms plus a power distribution board also makes your drone a bit heavier. So the weight is distributed along the arms, which also makes your motors work a little bit harder. So when you're looking at an ESC and you're determining what kind of amp draw you need, typically the motor that you're going to be running and the voltage that you're going to be applying to that motor will be on the products of the spec page. And usually they have a product page that shows the thrust generated for your specific propeller or the battery voltage that you intend to use. So what are the current requirements for your FPV build? Well, it's kind of up in the air with that. Typically what I do is I buy an ESC that's overrated for my application. That just gives me better performance all around. But if you really want to get down to the nitty gritty, you can always find the motor tests that are associated with the motor that you intend to use for your FPV build. And what you're going to want to look for is the amp draw generated at 100% throttle for the prop and voltage that you intend to use, and that will determine the proper amp rated ESC that you will need. And for more information on that, you can always go and check Mini Quad Test Bench. Ryan, he's a great guy. He's been doing this for a long time, been testing motors as long as I've been in the hobby. And if you're looking for thrust generated for a particular motor, you might want to check out his website, and we'll put a link down in the video description for you to go and check that out for yourself. So just want to give you a little warning here. Drawing more amps than your ESC can handle can also heat up your motors and cause your ESC to fail prematurely. Things that will increase your current draw can include things like high kV motors, large motors, or even propeller weight like your pitch and the length of the propeller itself. Now again, it is okay to use a higher rated ESC for your application. In my case, I like to use a high rated ESC for my application because some of the advantages I can get from a higher rated ESC means that I have less chance of overheating, better performance, higher efficiency, but more importantly, a longer lasting ESC. Now let's talk about some of the voltage ratings. Some ESCs support up to 6S voltage. You just want to make sure that they're compatible with the battery voltage you intend to use. Powering your ESCs with excessively high voltage can potentially fry your ESC, and no one wants to fry an ESC. Trust me, I've done it before. Now let's talk about ESC protocols. Now, ESC protocols determine the speed of the motor signal from the flight controller to the ESC, and that's chosen inside of your flight controller software, so like Betaflight, for example. There are 2 types of ESC protocols. You have analog and you have digital. And some of the analog speeds from slow to fast are PWM, which is the OG one from back in the day. That has a very long pulse width. It's no longer typically used in FPV drones, but it always works on ESCs when you need them. The next fastest one is one-shot 125, followed by one-shot 42, and finally multi-shot. And those are the 4 analog protocol speeds. The next 4 are going to be your digital protocol speeds, and that is in order from slowest to fastest at D-shot 150, D-shot 300, D-shot 600, and D-shot 1200. And you'll notice if you're an FPV guy and you've been in Betaflight before, you may have seen D-shot 1200 at one point in the past, but the Betaflight devs have taken that out because they see no benefit to the faster speed of DShot 1200, so we are stuck on DShot 600. Now, ESC protocols are independent of the ESC itself. It's what the flight controller uses to talk with the ESC at a certain speed. Now that you know the backend, let's discuss some of the anatomy of an ESC itself. So this is a typical 4-in-1 ESC. This is made by iFlight, and what I really like about this ESC is all the components are laid out on the board for us to discuss together. The first one you have is the current sensor, followed by a low dropout voltage regulator, and the question becomes, what are the actual components on the ESC that control the speed of the motor? First, you have the microcontroller unit, and then you have the gate driver, and that's sent out to the MOSFET. And finally, that signal is outputted to your motors in order to drive your motors. Then you have filtering capacitors. So what is the job of the current sensor? Well, it senses the incoming current and it feeds that information through the current wire from your ESC to your flight controller in order to display amp draw in the OSD. Amp draw has to be calibrated to display the proper current rating in your OSD. Now, what is the low dropout voltage regulator's responsibility, or the LDO voltage regulator? So low dropout voltage regulators are used to convert the incoming voltage, so your battery voltage, down to the proper voltage in order to power the microcontroller or the MCU on the ESC. They're used to power the microcontrollers because they can regulate the voltage even when the supply voltage is very close to the output voltage. Now, the MCU is a compact unit designed to govern a specific operation. It includes processor, it includes memory, and input-output peripherals. Now, the MCU's job is to store the BLHeli firmware, and that's essentially the brain of the operations. The purpose of the MCU is to process the incoming motor signal data and output the resulting calculation to the gate driver. Now, gate drivers are used to rapidly and completely switch the gate of the MOSFET. It accepts low power input from the MCU and produces the power input needed to switch the gate of the MOSFET. The gate driver ups the voltage to the required level in order to switch the gate of the MOSFET. So in essence, that's exactly what gate drivers do. They're used to drive the switch on the MOSFET. Now, some BLHeli 32 ESCs also contain the gate driver and MOSFET on a single chip. So MOSFET is an acronym for Metal Oxide Semiconductor Field Effect Transistor. And I know that's a mouthful, just don't get confused. It's kind of a fancy way of saying it's a switching regulator that changes voltage polarity thousands of times per second. So essentially, MOSFETs are used to drive your motors. They change the polarity of the stator poles and drive your permanent magnet on the motor belt around the stator. And lastly, we have filtering capacitors, and those are used to filter out the electrical noise and the ripple current in the power supply. It basically acts like a tiny battery when there are incoming voltage spikes in your electrical power system. It absorbs those voltage spikes similar to like charging a battery, and it will release that energy when there is a voltage sag towards the end of your battery. And that basically results in smoother and more constant voltage for the components on the ESC. Now that you know everything you need to know about ESC types, electrical ratings, protocols, and even anatomy, go out and pick up yourself a good ESC for that FPV build that you've been itching to put together. We'll see you guys next time. Drone Doc out.